Hello and welcome. Today we are going to solve simultaneous equations with three unknowns. Okay, let me start with the question. Okay, here there are three equations with three unknowns x, y and z. Simultaneous equations can be solved using either substitution method or elimination method, but in this question I don't think substitution method would work. So the only option is elimination method. So that means these three equations have three unknowns. So we try to eliminate one unknown, maybe x or y or z, depends, and then bring it down to simultaneous equations with two unknowns, and then you know how to solve them. Okay, so let us see how to eliminate one of the unknown. Now you have to look for easy option because this involves several steps. You have to cut down as much as you can. So we are going to look at the coefficients. I'm going to number them first. 1, 2 and 3. Okay. When you look at the coefficient of x, you have 3, 1 and 5. If I want to make everything same, probably I have to do so much. Here I have to make 1, 2, minus 3. Again, so much to do. Looks like this is a bit easy option because you have, maybe if I multiply something, it's easy to do that. So I'm going to try to eliminate. This is what I'm going to do, is to start with eliminate z. Let me see how I'm going to do that. So that's what I'm going to do. So if I take these two equations, maybe 1 and 2, if I simply add them, the z component will disappear. So I'm going to do that first. So for eliminating z, that's what my starting point is. So first I'm going to write equation 1 plus equation 2, because if I do, what happens, that part will disappear. So I'm going to rewrite them so that's easy. So the first equation is 3x plus y minus z equal to minus 3. This is my 1. I'm rewriting it so that you don't get confused. The 2 is x plus 2y plus z equal to minus 3. This is my equation 2. So what I'm doing is I'm doing 1 plus 2, which means I'm doing it again. I'm just writing this the first step, and I'm doing 1 plus 2 gives me, that's what I'm going to do. So that's why I just rewrite the equations. When I do that, 3x plus x gives me 4x. Then 1y plus 2y gives me 3y. And there is no z part. It just gives me minus 6. See, this is a new equation. I'm going to call them, I've done 1, 2, 3. I'm going to call them as 4. I'm just going to keep this. 4x plus 3y is minus 6. I'm going to keep this. So now I have to use as to get rid of z. Probably I'm going to use this time 2 and 3, because if I multiply this by 2, then I can eliminate z. So that's what I'm going to do. So now I'm going to do is I'm going to use, I think I should change this to use 1 and 2. So use equation 2 and 3. That's what I'm going to do. We'll see how. That's the thing I'm going to do. Use 2 and 3. So what I do is I'm going to equation 2. I have to do something. So I'm going to write equation 2 by number 2. Equation 2 by number 2, that gives me equation 2, which is this, by number 2, it gives you 2x plus 4y plus 2z equal to minus 6. This is a new equation. I have to number them. I have up to 4. Now I'm going to call this as 5. But for 3, I can write as it is because there is nothing wrong in it. I'm going to write 5x minus 3y minus 2z equal to minus 13. This is my original equation. I'm not doing anything with 3. I'm writing this as 3. So now I have to get rid of the z. So for that, in fact, in this case, I have to add them, not always subtract. This time I'm again adding. So when I want to add, so that means I'm adding which two numbers? 3 and 5. I'm adding equation 5 plus equation 3 gives me, when I do 2x plus 5x, which is 7x, and this gives me plus y, and that disappears, leaving with minus 19. So this is a new equation, and I'm going to call this as, because I've done up to 5, I'm going to call this as 6. Okay, so now what happened is, I have started with 3 equations with 3 unknowns. Now I end up having only 2 equations with 2 unknowns, which is, this is one, the other one is this, which is 4x plus 3y is minus 6. This is my equation 4. So equation 6 and 4, this one, this has 2 unknowns, of course 2 equations. So now we know how to solve this kind of equation. We learned how to do elimination method. So now I have to start thinking of eliminating another unknown. In this case, I think it is easy to eliminate y. So we're going to try that again. I'm starting with equations, which is 7x plus y equal to minus 19, and then 4x plus 3y equal to minus 6. I'm rewriting it so that we can start from this beginning. This is the, and this. So our goal now is to eliminate one of that. Obviously, I think eliminating y is easier. So I'm going to multiply equation 3 by number 3, which gives me equation 6 by 3, which gives me 21x plus 3y equal to minus 57. And this is my equation 7 because it's a totally different equation. So now I'm going to use 4 and 7. So if I use that, I'm going to probably write 4 minus 7. It's easy to subtract that way. Okay, if I do 4 is this, 7 is this. If I subtract 4x, take away 21x gives you minus 17x, and this disappear, leaving this with plus 51. If I divide by minus 17 both sides, then it gives you x equal to minus 3. Okay, now we just 7, I'm going to call this as 8. Okay, so I found the value of x. In fact, we have to go a long way. We still have to find y and then z. So what I'm going to do is, I'm going to sub the value of x into one of these equations, so you can find y first. Probably I stick with 6, it's easier. So what I'm going to do is, I'm going to sub, maybe I can write x equal to minus 3, or the number 8 into equation 6. So equation 6 is 7x plus y equal to minus 19. So I'm going to sub here. So 7 times minus 3 plus y equal to minus 19, or minus 21 plus y equal to minus 19, or y equal to minus 19 plus 21, which is 2. So now we have x and y. I can write this maybe another number, which is 9. Okay, we got x and y. The question is not over yet. So we have to go back to the original question where you have to find x, y, z. What I can do is I can sub the x and y values in one of this. So maybe I want to choose 2. So I'm writing 2 again. So equation 2. So I'm going to use equation 2. So equation 2 is x plus 2y plus z equal to minus 3. I'm rewriting so that minus 3. Minus 3. So I'm going to sub. So this is minus 3. This is my equation 2. So now I'm doing sub 8 and 9 into equation 2. So equation 2 we know is x plus 2y plus z equal to minus 3. So when I want to do that, x is 8, which is minus 3. You can either say this, either this or that. So minus 3 plus 2 times 2 plus z equal to minus 3. When I sub in, this becomes 1 plus z equal to minus 3, or z equal to minus 4. So we got the values of x. So therefore the solutions are x equal to minus 3, y equal to 2, and z equal to minus 4. Again, if you want to check your answers are right, you go back and sub these x, y, z values into the equations and see whether they make sense. Okay.